All right, guys, so we're going to start Unit 9. That's going to be exponential functions. This unit's not super long. We're going to try what's called a flipped classroom, which means y'all are going to take the notes when you guys are at home, and then you're going to have the whole class period to work on homework in class. I hope that this is really going to let y'all ask a lot of questions and not be stuck on homeworks when you guys are at home, and give us a little bit more time to kind of work through the problems that you guys are having. I'm going to try to keep the videos short. This first one might be a little bit longer just because we're introducing a lot of information. But then after that, the videos are going to try to stay, under 15 minutes so you're not spending hours and hours at home doing this stuff. All right, so let's get started. So exponential functions, you have two different kinds of exponential functions that you're going to see for the parent function. You have this one right here. This is called a growth function. So from left to right, it's growing. That you have this one right here. That one's called a decay function. So our domain is always going to be negative infinity to positive infinity, or we can say that x is an element of all real numbers. Our range, just like in rationals, we have what's that asymptote. So you have this horizontal asymptote that's right here. So that means we're never going to actually hit 0, but then we're going to go up forever. So making sure that you use a parenthesis around that 0. This is an increasing function. And I just talked about asymptotes. You have that asymptote at y equals 0. All right, your other one, we're going to skip the middle for a second and we'll come back to it. So your next one's a decay function. So the domain on this one, we're still going left and right forever. So we're going to have that all real numbers, or however you want to write that. Our range is still going to be the same. So the lowest it's going is still 0. The highest it's going up forever. But this is a decreasing function. And then the asymptote, again, still at that same spot. Now, in the middle, we're going to talk about what makes it growth, what makes it decay. So your basic function is going to be f of x is equal to a and then b raised to the x power. That's like your parent function general form. Your a can never equal 0, and then your b is going to be a value that's greater than 0. So you're never going to see like -7 as your b value. Your a is your initial value. So when we get to word problems and stuff like that, it's going to be whatever your initial value is. And then your b value is what's called the base. If b is greater than 1, which is like over here, our b value is 2, then we're going to have what's called that exponential growth, which I talked about earlier. And if your b value is between 0 and 1, like your fractions, like we have over here, that's when you're going to have exponential decay. All right, so that's kind of our basics. Now let's keep on moving. Remember, because the notes are on video, if you ever get lost, you can always pause, rewind, slow down, whatever you guys need to do to help you out. So all exponential parent functions are going to go through the point 0, 1. So their y-intercept is going to be 0, 1. And then they're also going to have a point at 1, comma, b. So whatever your b value is, it could be 2, 5, 7, 9, whatever it is. The parent function of an exponential function crosses the y-axis at 0, 1 because anything raised to the 0 power is always 1. So think if this was 2 raised to the 0 power, all right, that's still just going to give you back a 1. And you can kind of go from there. All right, let's move on to that next page. Now we're going to talk about all the different transformations that we're going to have. So transformations follow the same thing we've been doing this whole entire time. So we've talked about shifting, we've talked about reflecting, we've talked about stretches, compressions, all that stuff. So this is your basic formula. We added a little bit to it from the front side. All right. So your a value, if you have positive, it's going to stay this direction. It's going to stay above that horizontal asymptote. If you ever get negative, that's when you reflect. So it's going to come and it's going to be down here below. If your a value is greater than 1, then you have that vertical stretch. And remember, if your a value is between, this should have a 0. So if you have that fraction, that's when you get your vertical compress. Your b value tells you whether it's growth or decay. And then your H value shifts you left and right, just like it has been every other unit. And your K value moves you up and down. This note's important, so it says note, if you shift something up and down, that's gonna move your horizontal asymptote with it. So usually your horizontal asymptote's at y equals 0. If you shift it up 3, then it's gonna be at y equals 3. So it's gonna move that up and down. All right, so we're gonna talk about this example. So on this example, describe how the graph negative 2x plus 3 plus 2 would be different from that parent function of just raised to the 2x. So we need to go through and we need to think about what different transformations are happening. So this one has 3 transformations that are occurring. So you can kind of start to work through and you're looking for those 3 different ones that are happening. So if we look at this negative first, we know that that's going to be a oops, I'm sorry, I went to the wrong part. Right here, this negative first we know is going to be a reflection across where? So remember, when it's out in front, that's across your x axis. Then we know this plus 3 right here. So remember, anything that happens with x is always opposite. So plus 3 is going to move us left 3 units. And then finally, this plus 2 at the end is going to move us up 2 units. So those are your 3 that you see there. Next thing says, if you knew the basic points, so say you knew what the points were for your original, how would you get the points of your new one? All right. So you have to think about what the rule is that's happening. So to go from your original to go to your transformed, what's happening to your x's, what's happening to your y's. So for your x's, out of the 3 transformations that we said, the only one that's going to affect our x is going to be the fact that we went to the left 3 units. All right. The other 2 transformations are going to affect y values. So to get from our original x, if we go left 3 units, that means we're going to have to take whatever our original is and we would have to subtract 3. That would give us your new x. All right, if you take your original y from that parent function, now you have 2 things that are happening. It's going up 2 and it's getting reflected. All right, so from your original y to reflect it, we're going to have to make that point negative. So we're going to have to make that point negative right there. And then we're also going to have to say that went up 2. So if we take our original y and we make it negative and add 2, that's going to give us our new y. And then it says to go ahead and make a table. So if we were to make a table, you're just picking x values, y values, and you're plugging them in. All right? So you can pick whichever ones you want. X, Y. You can use your original and use this rule, or you can just go straight into your new one. So let's say we wanted to try the points -3, -2, -1. We would take those points and we would plug them in right here, and we would see what we get. So if we plug in -3, -3 plus 3 is going to give us 0. Anything raised to the 0 power is 1. So then you have -1 plus 2 is going to give us a +1. And then you would just continue to plug in. You'd get a 0, you would get a -2. That's just taking these x values again, plugging them into that equation. Then you can go through and you can graph it on the grid. So we have the point -3, 1. We have the point -2, 0. We have the point -1, -2. Then you have to think about where your horizontal asymptote is. So again, if I have my original at 0, but I move this whole graph up 2, that means I have a horizontal asymptote that's right here. So that's my horizontal asymptote. Originally, it would have been up here, but because we reflected, now it's going to be down here. And so our graph is going to look something like this. Identify what your domain and range is. Your domain's always easy, okay? So your domain is always going to be all real numbers. You can plug in whatever X value you want. That's not going to matter no matter what the transformations are. Your range, though, is when you really have to look at the graph that you've created. So in the graph we've created, it's going down forever, but it's going up until you hit where your horizontal asymptote is. So our range is going to go from negative infinity until we're at that 2, but never including the 2 because you never actually hit that asymptote. And then it says where would the asymptote on the graph be and explain why. It would be at y equals 2 because we shifted up 2 units. All right. We're going to do one more example. So when we do our one more example, you guys can kind of see, you can pause and see how far you can get yourself, but kind of going through. So let's look. This one I'm going to kind of show you how to do it without making a table. So you can kind of see what it would look like kind of without a table, and then we can kind of build from there. So state the changes that would happen to the coordinates, obtain a different graph. It says to make a table. I'll show you the table, but I want you to see how it works without the table also. Then state the domain and range of a given function and the equation of its asymptote. All right, so on this one, it says note, you must factor out the negative because you want to determine what your horizontal shift is. Oops, sorry, I'm not even on there for you. So if we look at this first one, this part that's up here, you have to start attacking this part. All right. So anytime they go something in front of the X, what's behind it has to be in parentheses. So if we were to factor out the negative, that would leave us with X plus 3. And then that's going to be 2 separate transformations that are happening. And that's going to matter because plus 3 versus minus 3 changes things. So let's go through and let's name what our transformations are. So this negative is going to be a reflection. But because it's up with the X, this is going to be across the Y axis. All right, so that's going to be our first one. Once we factored out this negative, this became a plus 3. So this means that we are going to move left 3. And then finally, that minus 2 is going to move us down 2. All right, so those are kind of, again, that's what our basic functions are going to look like. So if we start to work through kind of what's happening, all right, we can go through and we can do it a couple different ways. So I'm going to show you the table and I'm going to talk about how to do it without it. So if you think, I'm going to show you the table a little bit differently this time. So let's say this is your basic parent function, 2 raised to the x, and then you have your 2 raised to the negative x. Oops, let's change it to plus 3 minus 2. All right, let's talk about some of the basic things that you're going to have in your raised to the 2 of x. All right, so if you have something that's raised to the 2, or 2 raised to the x power, all right, you're always going to have the point 0, 1. Because if I plugged in a 0 here, I'd get 1 back. If I plugged in a 1 here, I would get a 2 back. If I plugged in a 2 here, 2 raised to the second power, I'd get a 4 back. So that's like my basic parent function. All right, and you want to become familiar with your parent functions. Now let's talk about what's going to happen if I plug in and what my rule is going to look like. So just like we did on the other side, you have to think about to get from my first x to my new x, what's happening? Well, now you have 2 things that are happening to your x. This is going to change your x value. This is going to change your x value. So for my original, I'm going to make my original negative. That's going to reflect it. And if I want to move it left 3, that's subtracting off 3 units. So minus 3. The reason that this gets a little tricky is because the -3 + 3, it always works it's kind of weird in your head. So, and then for your y values, the only thing that's happening is we're moving down 2. So you're gonna subtract off 2. All right, so what is that gonna look like? So for our x values, my original x was 0. 0 right here, -0, that's still 0, but now I'm subtracting 3. So now my new point is, now my new point is -3, comma, I need to find out what my y value is. So let's find all our x values first. Take 1 and plug it in here. -1 minus another 3 is gonna give me -4. Take 2, plug it in here. -2 minus another 3 is gonna give me -5. Now let's figure out what our y values are gonna be. Y value, take your y value, plug it in here, moving it down 2. 1 minus 2 is gonna give me -1. 2 minus 2 is gonna give me 0. 4 minus 2 is gonna give me 2. So that gives me all these new points that I can use. So -3, -1, -4, comma 0, -5, comma 2, and that gives me points to start with. All right, you have to think about now, because we moved it down 2, you know your new horizontal asymptote is at -2, so it's down here. All right, and instead of it building this way, we reflect it across the y-axis. So now it's gonna come down this way, like this. What's your domain? All real numbers. What's your range? The lowest it goes to is -2 up to infinity. Our asymptote is at y equals -2. All right, that is a lot of information. So with that information, all right, we're gonna do 3 in class tomorrow, kind of work on that, and then after we do number 3, you guys will get the chance to work on the homework. So make sure you're getting these notes down, starring any questions that you guys have so we can work from there. All right, I'll see y'all in class.